Now, in this video, we are going to take up one more program to find the roots of the quadratic equation by using else if ladder condition. So to do that, first, what are the roots of the quadratic equation? The roots of the quadratic equation is minus b plus or minus root of b square minus 4ac by 2a. So this is the condition or the roots. So we have one roots are equal, the roots are distinct, and also the roots are complex. So to write this program, so first what I need to do is first we will include stdio.h, the conio.h and math.h. So why exactly math.h will going to come into the picture? Because when the roots of the quadratic equation, what it says is it is minus b plus or minus root of square root. Since we wanted to calculate the value of a square root, the square root will come under the mathematical function. So therefore we have to include the header file as math.h. So we will going to write a user defined function if it's quadratic. So since here the roots what we are going to get is all of with the decimal point. So we will going to declare the values of a, b, c as a float function or the float variable. Quadratic, float a, float b and float c. So first we are going to consider the roots which is x1 and x2. So since we have the float variable, so naturally the result what we are going to get is also float. So float x1 comma x2 and then discrete value, disc values. So first we will going to take up every time we cannot write b square minus 4ac. So for that reason we will going to declare that b square minus 4ac, that is b into b minus 4 into a into c is equal to disc. We are going to consider that as one particular function, or the first one particular as the variable, as the both disc is equal to b square minus 4ac. So the first condition, if that disc value is greater than 0, then what happens? So the entire root, if this is greater than 0, the minus b plus the square root of disc by 2a, and x2 will be equal to minus b minus square root of disc by 2a. So then the roots are distinct. So printf, whatever the value, the roots will going to be distinct. So printf x1 is equal to percentage 0.2f slash backslash t. So what exactly it does is it will going to controls the number of decimal point, the number of digits after the decimal point. And since we are giving the tag, so x2 will also be on the same line, which is x2 will be equal to percentage 0.2f backslash t comma x1, and the roots which we are to print is x1 comma x2. If that condition is not true, then else if disc is equal to 0, then the roots are real, x1 is equal to x2 which is minus b by 2 into a, and the print the roots are equal, that is x1 is equal to x2, that is equal to minus b by 2 into a. Then printf x1, again we are controlling the number of decimal point after the number of digits after the decimal point, which is x1 equals point percentage 0.2f backslash t, and x2 equals 0% 0.2f backslash t x1 comma x2. So yes, if that is also not true, then what happens? x1 is equal to minus b by 2 into a, and x2 equals square root of fabs, that is the absolute value of the disc value by 2 into a. So printf, the roots are complex. The first root is percent 0.3f plus I percent 0.2f backslash n and x1 comma x2. The second root is again a plus I into b and a minus I into b. So that is 0.3f minus per I percent 0.2f backslash n x1 comma x2. So return those values. So here the main function is float a comma b comma c, then printf, enter the coefficients, scanf, read those coefficients, that is a, b and c. So once you do that, quadratic a comma b comma c, so get character function we are going to use to get this. First we are going to for the first tracing, enter the coefficients. We are going to take the values of a is equal to 1, b is equal to minus 5 and c is equal to 6. The roots are distinct, so the value of x1 will be 3.0 and the value of x2 will be equal to 2.0 by calculation what we do. Similarly, for the second coefficient, we have a is equal to 1, b is equal to minus 4 and c is equal to 4. The roots are equal. In that case, x1 is equal to x2 which is equal to 2.00. If we wanted to given the backslash t, so x1 and x2 are printing in the same fashion. Then in the enter the coefficients, a is equal to 6, b is equal to 2 and c is equal to 4. The roots are complex. The first root is minus 0.167 plus 0. Plus I 0.80 and the second root minus 0.167 minus I 0.80. So this is how you will be able to solve the roots of the quadratic equation by considering the else if ladder statement. Now we are going to try to solve this problem by using the code blocks. So to do that, so first we want to go in, log into the code blocks, and now we will write the simple program for this. So to do that, so first we have to include all the three header files. So include stdio.h, then include conio.h, then include math.h. So then we have quadratic. Then the roots of this the roots we will going to get is the floating variable. So naturally we will going to get float a, float b. The variables what we are declaring is also in the float, because all the coefficients are in what we going to get. The roots will be always in with the decimal point. So once you do that, so here we will have float the roots x1 comma x2 comma disk values, that is the one which you want to take, minus b, that is b square minus 4ac, that is the one which we are declaring as disk, which is equal to b star b minus 4 star a star c. Once you get this, so now we are going to apply the if condition. If disk is greater than 0, okay, then we have the condition. What is that? x1 will be equal to minus b plus, so we are going to open the bracket, so minus b plus sq or t, okay, disk func that divided by, so one is for this and the other one is for this, by 2 star a. Okay, then we will get this. Then x2 equals, or x2 equals minus b minus sq or t disk by 2 star a. 2 star a. Then okay, then printf, what are this? The roots are distinct. The roots are distinct. Okay, so backslash n, and then you come out of this. Then again, what are the roots? Printf, open this, x1 equals percent 0.2 f backslash t, then x2 equals percent 0.2 f backslash t, then you come out this one and you type x1 comma x2, that is the roots which you will going to get. So then you will get this. Once you get this, so we are going to have a flower bracket. Then else if disk value equals 0, we are comparing the value of disk value as 0 now. Then open this, then here x1 equals x2, which is equal to minus b by 2 star a. Okay, then printf the roots are equal. The roots are equal. Okay, sorry, backslash n, and then enter. Printf x1 equals percent 0.2 f backslash t comma, sorry, no, it's okay. Then x2, capital X2 equals percent 0.2 f backslash t comma x1 comma x2. So we have this, and then you come to this. Then if this condition is also not satisfied, else what is the other condition? Else we obviously should be less than 0. So then else x1 equals minus b by 2a, x1 equals minus b by 2 star a. Okay, then x2 equals sqrt fabs, open the bracket, disk, then you take this by 2 star a, 2 star a, sorry, then close this. Printf the roots are complex. So once we say the roots are complex, so that means you will going to have a plus ib and a minus ib. Printf the first root equals percent 0.3 f plus I 0.2 f backslash n, then you say x1 comma x2, okay, or x1 x2, okay. Then printf the second root equals percent 0.3 f minus I 0% 0.2 f backslash n, and then comma x1 comma x2, then you close this, then you come to this and close this braces. Now here you just say return those values here, and then finally it comes out of this. Now we will going to write the main function. So we go for main, then open this, then we have a float a comma b comma c, then printf enter the value, enter the three coefficients of a comma b and c. Okay, once you do that, then scanf percentage f and read those coefficients a and b and c. Then quadratic a comma b comma c, then get ch function, and then finally close it. So this is how you will be able to write this program. I will just file, I will go to save file as, I will save this now, one, and save it. Yes. Now we are going to run this. So here we will continue this. So I will just I will say Now we are going to run this program. So to run this program, we have removed this because that is the one which has given the problem, which is conio.h. So now once we remove this, so first we are going to run this program now. Once you run, they enter the three coefficients of A, B, C. So first we are going to enter the coefficients of A as 1 and the coefficient of B as -5 and the coefficient of C as 6. So once it calculates, the roots are distinct. So x1 will be equal to 3.00 and x2 is equal to 2.00, and of course press any key to continue. Then again, that is, its condition is satisfying this condition. Now else if, now what happens we will see. For the second coefficients, we will going to take the value of x is equal to 1, then we have -4 and we have the c is equal to +4. So the roots are equal, x1 is equal to 2 and x2 is equal to 2. Now when you are trying to do the third one, we have here run, enter the coefficients, a is equal to 6, b is equal to 2 and c is equal to 4, and then here the first root is -0.167 plus I 0.2f. Let us see what is the problem there. And the second root -0.167 minus I 0.80. So here there may be some mistake. So what we have here, percent 0.3f plus I, here it should be percent 0.2f backslash n x1 and x2. Now we will going to save this and run it now. So ABC, the value of A as 6 and the value of B as 2 and the value of C as 4, and when we enter even that 0.2f, still we are getting this I 0.2f. So that is only, again that is because I percent 0.2f plus I 0.2f backslash n x1 x2. The roots of this complex root. So here just you run this again, we will see 6, 2 and 4. So now again we are getting this, okay. That is only because we might be saving this file. Save as, I will take 121212 and I will save this. Again I will run this compiling. So that is basically because it was not updated the data. So we will see, check now, 6 and 2 and 4. Now we can see that the value has been considered. I plus 0.8 minus I 0.80. In the previous case it was not considered. That is basically because we have not saved the file and we have not updated the file. So that is the reason why it was not able to consider. Once we saved as a different file name and we run this program, we were able to execute the changes. So this is how you will be able to find the roots of the quadratic equation by considering else if ladder statement. Thank you.